There's a lot of news coming out about new constellations of satellites these days. SpaceX is planning to launch 7,500 satellites as part of a constellation. There are three other constellations that were approved on the same day as SpaceX's, and even Canadian companies are planning 13 constellations to be launched in the near future. These satellites can revolutionize the way we monitor our planet and the way we communicate with each other. And while these plans might not all come to fruition, one might wonder, what if they do? With so many satellites in space and more to be added, can we continue to sustainably use space? Or are we going to destroy the orbits around Earth the same way we are destroying the surface of the Earth? Well, let's talk about it. A couple of days ago, I was watching WALL-E, and this sequence came up. While it's not physically correct, satellites need to orbit around Earth so as not to fall down, it does show what can happen if we do not take care of the orbital environment around Earth. So in this series of videos, I will try to share with you a bit about the problem of space debris and possible solutions to it. Let's begin. The first thing you probably would like to know is what is up there right now? Well, there are two types of objects orbiting around Earth. First, we have operational spacecraft, which, as their name suggests, are satellites that are still in use and any other spacecraft that is still in use, like the International Space Station. As of April 2018, there are a total of 1,886 operational spacecraft in orbit. If you look at these based on the number of objects, the United States, China, and Russia have the largest number of spacecraft in orbit, followed by other countries. About half of these satellites are in commercial use. These operational objects make up only 40% of intact satellites in orbit and about 10% of the total number of objects tracked around Earth. Then you might be wondering, what are the other objects there? Well, there are what we call space debris and, well, some people like to call space junk. These include things like dead satellites, which are basically satellites that have completed their mission or have ran out of fuel or have had a system failure of some sort and cannot continue to provide services. They include lost equipment and tools that are usually objects lost during an extravehicular activity, including things like gloves, wrenches, cameras, and toothbrushes. But have also included sometimes objects that were discarded as garbage. Another group of objects there that are not really useful are rocket topper stages. These are the parts of rockets that help speed up the satellite to reach a speed that helps them maintain their orbit, and after they have been used for that function, they are usually discarded. There are also a bunch of objects up there that are a result of weapon tests. There have been technologies tested by different nations to see if you can destroy another nation's assets in space. Both the United States and Soviet Union tested anti-satellite weapons during the 1960s and 1970s, and China did such a test in 2007, which led to the creation of more than 3,000 trackable objects around Earth. Another source of these not so useful objects are debris collisions. Basically, this is the result of the collision between a satellite that is out of control and any other objects that is up there. For example, in 2009, Iridium-33, which was an operational satellite, collided with Cosmos 2251, a decommissioned Russian satellite, and this added about 1,500 trackable objects to the objects orbiting around Earth. Another source of this unwanted, more or less, objects around Earth are explosions. Satellites and other objects that are used for space travel usually contain fuel and batteries, and these fuels and batteries can lead to explosions at times, which will increase the debris. While 46% of operational satellites are US satellites, when looking at the number of objects being tracked, you start seeing a different story. About 1/3 of the objects are of Russian or former Soviet Union origin, with another third being Chinese. Looking at the mass would also be a different story because the number of objects doesn't always correspond to the mass of the objects. It is estimated that There are about 500,000 objects larger than 1 centimeter orbiting around Earth, but we can only track about 20,000 of them that are larger than 10 centimeters. Rather than the number of objects, their location is also important. Not every orbit around Earth is affected the same way by space debris. There are specific orbits that are more crowded with debris due to their specific applications. As you see, there's a peak at about 35,000 kilometers, which is the geostationary orbit. This is the orbit that would face the same location on Earth at all times, and many communication satellites would use such an orbit. In lower altitudes, there is a peak at about 700 to 1,000 kilometers, which is typically the orbits used for Earth observation applications. Results from simulations by NASA show that the fastest growing debris region around Earth is at about 800 to 1,000 kilometers, where there are massive payloads. There are also rocket bodies, and there's a higher probability for collisions. So we have so many objects in space, and they are mainly distributed at 700 to 1,000 kilometers and at 35,000 kilometers. So what's the big deal with this? When we started sending objects to space with Sputnik and Explorer 1, the mentality was that space is big enough for us to send whatever we want without any consequences. Some people call this the big skies policy. However, as we started using space more and more, scientists in the 70s started to have some concerns. You see, the orbits that we are interested in for most applications are limited. As we put more objects in those key orbits, they start filling up. With so many objects around Earth, adding more without removing any of the existing objects gets us closer and closer to what has been dubbed Kessler syndrome, a scenario where there are so many objects in orbit that collisions between them dramatically increases the likelihood of future collisions, destabilizing the usefulness of orbits and increasing the risk of space missions. This can halt our use of space, as the risk of losing satellites to these collisions is much higher than the benefit that they bring for us. While larger objects in space are easy to avoid by maneuvering, smaller ones are not. You have to remember that these small objects are moving at speeds of thousands of kilometers per hour, which means they have a lot of energy. A small object can collide and just go through what it is colliding with, like a bullet. There have been examples of these small objects hitting the International Space Station and damaging things like solar panels. There are also a higher risk for spacecraft that do not have maneuvering capability, such as small satellites that are built by universities, to be hit by these objects. For example, Pegaso, the first Ecuadorian satellite, seems to have had such a fate, being hit by a very small object and destroyed. Another issue is that what goes up has to come down. Objects in orbit lose altitude over time due to the drag force of the very thin atmosphere that exists around them. For example, the International Space Station may lose up to 70 kilometers in altitude every year and has to be boosted up periodically. The problem is, if large objects like rocket bodies that have very aerodynamic shapes re-enter our atmosphere, they might not necessarily burn up completely. There are several examples of tanks surviving the trip back to Earth. Of course, there are ways to do a controlled deorbit to make sure these objects land in oceans to reduce the risk, but this would cost fuel, which basically means it would cost money. So most of the objects actually re-enter in an uncontrolled deorbit. We've been pretty lucky with these reentries, as the only reported case of debris hitting someone was in 1997 in the US. But it's not always fun and games. In 1978, the Cosmos 954, a nuclear-powered satellite, reentered over Canada, affecting areas in Nunavut, Northwestern Territories, Alberta, and Saskatchewan with nuclear waste. Finally, one has to remember that more debris means the need for more maneuvers so as not to hit those debris. So this means the satellites that are up there have to kind of move around and maneuver around these debris fields. This means increased use of resources such as fuel, reducing the satellite's life, which will in turn mean we'll have more debris. So with this in mind, I think we can all agree that space debris is an issue, and an important issue. It can affect our future use of outer space and technologies such as communication and navigation that we rely on daily. But what can we do about it? Well, we will go into that in the next video. Thank you for listening to this video. This was my first time doing a video. I'm going to do more of these videos in the coming months, so if you have any input, any suggestions, any ideas for future videos, just let me know in the comments, and we'll stay tuned for the next video on space debris.